for any function f, so this is function f, function f, function f. It's a continuous, yes, there is no gap, there is no hole, so this is continuous function. And it's differentiable, yes, this is differentiable. Why? When we have this case, do you remember, or when we have this case, the functions are not differentiable, but the other things, so they are differentiable. We talked this before. There must be at least one point. Be careful the keyword at least one. What does it mean? It could be one, it could be two, it could be three, it could be four, but minimum one between A and B, where the tangent line to the given function is horizontal. Now, one question. Tangent line horizontal means, isn't it f prime of x or f prime of x0 at the given point is 0? Can we say this? What is the y f prime means slope? What is the slope of the horizontal lines? It's always 0. Think a little bit. Correct or not? Not clear? I'm waiting your answer. The question is then one more time. If I have this case at this point, if I have a horizontal line, can I say that f prime at c equals 0? Can I say or not?
Yes.
Why? What is the slope of any horizontal line The answer is 0. So this is now horizontal line. Since this is horizontal line, it is 0. And one more thing. If you have horizontal line, it means that, for example, for this graph, this is the maximum point or this is the minimum point. Can we say here at that point, since slope is 0, the function gets its maximum or its minimum. So these are called critical points. We will discuss this later. So where the function gets its maximum or its minimum, this is the critical points. So the function gets its maximum or the function gets its minimum if you have horizontal line. So it here max, and here it's mean. Here it is max. Here it is mean. Any question till here? Max, mean? No. Now, what my question guarantee, what my question says, what my Rolle's theorem says from the beginning, if you have closed interval from A to B, if your function is continuous function, it says that there must be minimum one number between A and B such that f prime at C is equal to 0. That's it. One more time. If you have closed interval, if you have continuous function, and that function is differentiable there, so there is minimum one point such as f prime C is equal to 0. So I am making extra comment on this. So at that point, since we have horizontal tangent, horizontal line, since the derivative is 0, this could be maximum value of the function, or this could be minimum value of the function. There could be only one C node, at least one point. It means it could be C1, it could be C2. As you see in the graph, I can draw. That's it. Now I am passing. Now, one more time, suppose that f is continuous on the interval, differentiable on the interval, and fa is equal to fb. This is now second theorem. Fa is equal to fb. You know, this is now a, this is now fa. Now this is b, this is now fb. So fa is equal to fb. If this is given, till here, this is given. This is hypothesis. Now it says then, so result, Conclusion, there is a number C such that f prime of C is equal to 0. Is it okay? Is it clear from the graph? Since starting point and ending points are same, that means you are going up and you are going down. That means there must be somewhere here tangent line, or imagine like that your graph must be here. Since starting point and ending point comes the same point, it must be anywhere one point that at that point when you draw you will get a tangent line. So it will be max or mean. Any question? So what is the hypothesis here? If FA is equal to FB, two different points, but their Y values are same, so you can always find a number. Be careful, it says a number such that the derivative is equal to their 0. Any question?
No.
Now example, how can we use this theorem? Find the value of C satisfying the conclusion of the Rolle's theorem for the given function on the interval. I mean, it says that given function and interval satisfy the Rolle's theorem. So what was the Rolle's theorem? It was if FA is equal to FB, there must be a point C such that f prime of C is equal to 0. This is our theorem. Okay? Given and result, output. So let's check it. What is F0? And FA means F0, FB means F1. What is F0 and F1? Let's check it. F0 means 0 cubed, 3 times 0 squared, 2 times 0 plus 2, so this is 2. F1 means 1 cubed, 3 times 1 squared, 2 times 1 plus 2. So this is 1 minus 3 plus 2 plus 2. So 1 minus 3, negative 2 plus 2 plus 2. So this is 2. So what do we see? F0 is equal to F1 is equal to 2. So by the theorem, there should be a number C such that f prime of C is equal to 0. So what am I going to do? Right now I will calculate f prime. So what is f prime of x? 3x squared minus 6x plus 2. So we said that there must be f prime of c is equal to 0. So 3c squared minus 6c plus 2 is equal to 0. So this is quadratic function. By using factorization or by using the quadratic formula, I should find something. Factorization, let me try. It is easy or not, I don't know. If I say 3 and 1, 3, 1, 4, no, 1, 3, 6, 4. So it is difficult. Let me use quadratic formula. Delta is equal to b squared minus 4ac. So delta is equal to 36 minus 4 times 3 times 2, which is 36 minus 24, which will be 24, 34, 12. So the x will be negative b, which is 6 plus minus root 12 over 2a, which is 2 times 3. So it will be then 6 plus minus root 12 divided by 6. So it will be 1 plus minus 1 over 6 times root 12. By the way, root 12, this is equal to 4 times 3, so 2 root 3. If I write 2 root 3, I can simplify. So 1 plus minus root 3 over 3. Now be careful, dear ladies. My interval is from 0 to 1. My interval is from 0 to 1. So 1 minus root 3 over 3 and 1 plus root 3 over 3. So let us start with this. 1 plus root 3 over 3, can it be here? 1 plus root 3 over 3, can it be?
No.
No. Then omit, cancel, remove. 1 minus root 3 over, yeah, it is somewhere here. I don't know where, but it is somewhere here. So this is now my number C. Okay, the C is equal to 1 minus root 3 over 3. You can use the calculator and you can say the approximate what is that. Now let me show you what is the result. Yeah, 1 minus 1 over 3 times root 3, which is 0.5.